water is being pumped up a 100-meter hill as shown below from one reservoir at a constant rate of 200 kilograms per second into another. Assume the water is at rest in both reservoirs. What is the kinetic and potential energy of 200 kilograms of water in both reservoirs? So what's happening here is you have basically a tank up the top, and then you got your pump and a tank down the bottom. So here, the kinetic energy equals the potential energy, which equals 0 here. And at the top, the kinetic energy equals 0, and the potential energy equals mgh, which in this case is 200 times 9.81 times 100. So that would be 200 times 981. So that's 196 kilojoules. Now, you might be noticing, well, something's not right in this picture, because at the top the water has this much energy, the 200 kilogram blob, and down here the 200 kilogram blob has no joules of energy. So what's happening here? Well, what's happening is that you have a little pump, and the pump is taking the water in, giving it some kinetic energy, so it can travel up into the top tank. That's what's happening here. So that kinetic energy is what's missing from the equation to keep it balanced. So the 196.2 kilojoules at the top, that's equal to 196.2 kilojoules at the pump stage. So let's see, how fast is the water being pumped? Well, since we've established that this is a kinetic energy down here, we can say that this is equal to a half m, which is going to be 100 times v squared. So 196.2, oops, okay, so divided by 100 and square root, so 44.29. So we get V is 44.29 meters per second here. So that's how fast the water is being pumped. The water got its kinetic energy from the pump, therefore per second how much work is the pump doing? So what's happening is each second the pump is providing the water at ground level with 196.2 kilojoules per 200 kilograms. So what's happening here, you have to picture it like this. You have 200 kilograms of water. This has 0 joules of energy. Then the pump gives it 196.2 kilojoules, so that it then has kinetic energy, and this kinetic energy is 196.2 joules, and this then will become potential energy of the same amount. So the energy is conserved here. The potential energy came from kinetic energy, the kinetic energy came from the pump that put the energy into the water at ground level, and the pump has to be giving it this much energy per second. So what's happening is the pump is doing work. It's given or doing 196.2 kilojoules every second.